Today in Geometry, Chapter 8, Section 2, we're going to look at some parallelograms and use some properties to solve some problems. Let's talk about what is a parallelogram first. In a parallelogram, opposite sides are parallel, which means that AB is parallel to DC, and also that AD is parallel to BC. We also know that opposite sides of a parallelogram are congruent, which means that AB is congruent to DC, and also that AD is congruent to BC. A third thing that we know about parallelograms is that opposite angles are congruent, which means that angle D is congruent to angle B because those are opposite of each other, and also that angle A has to be congruent to angle C because those angles are opposite of each other. Let's use these properties now on this example to solve for x and y. When we look and we see what we have, we know that side DC is 12 right here. We know that the side opposite must be congruent to it, which means that x plus 4 has to equal 12. So now this just becomes a very simple algebra problem. We solve for x, we subtract 4 from both sides, and we get that x equals 8. Now we want to solve for y. Angle y is opposite to this angle right here. Angle A, that is y degrees, is opposite to angle C, which means that y has to equal 65 degrees. Okay, so we just applied those properties that we learned on the previous page. Okay, let's take a look at this quadrilateral, PQRS. All right, if we draw the diagonals through there, the diagonal goes from one vertex, skips one vertex, and goes to the other. So we're going to have a diagonal that goes from P to R, and we're going to have another diagonal that goes from Q to S. In a parallelogram, when you have diagonals, those diagonals bisect each other. And so that means that where QS crosses PR, that means that we're going to have this midpoint right here where all those intersect. That means that from PM, this right here, has to be congruent to MR, right here. Also, that also means that M has to be the midpoint of QS. So we have that QM is equal to MS, so that piece equals that piece. They bisect each other. With the information that we know about parallelograms, we can solve some things here. Number 1 says to find NM. N is here and M is here. Because we know that diagonals bisect each other, and from K to N is 2, then N to M must also be 2. K to M. Well, if K to N is 2, right here, and N to M is 2, then the entire distance from K to M then must be 4. Now we're going to have to use our heads a little bit. They want to know the angle, the measure of angle JML, this entire angle right here. So let's think about that for a minute. If we know that angle J right here is 110 degrees, then we also know that angle L is 110 degrees. So those two things together make 220 degrees. Now remember, this is still a quadrilateral, and any quadrilateral has 360 degrees in it. So if we take the 360 that we know that that's the total, that's our sum, and we subtract the 220 from those two angles, we're going to be left with 140 degrees. They have to be split evenly between this vertex here at K and this vertex here at M. So 140 has to be split evenly between the two. So we'll split that and we're going to get 70. Well, if we know that this whole thing is 70 and this piece right here is 30, then we know that this must be 40 right here. So if we want the entire angle JML, this whole thing right here, then we will find that that is 70 degrees. The angle KML, this angle right here, okay, we figured out was 40 degrees. let's review what we know about parallelograms. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. And the diagonals bisect each other. Those are the high points of what we need to know for this lesson. Hope everybody has a good day.